Now in this experiment, we are going to practice with this thing. It's the refraction cup that's inside your lab kit. Okay, so we're gonna fill that mostly up with water. Be careful because you're gonna make a mess if you fill it too far up with water. I've got it about 3/4 of the way full of water. And I'm gonna set it right on top of a white piece of paper and then on top of my protractor. We are going to, and then I've drawn my normal line right here at 90 degrees. We are going to have a bunch of different incident angles, and you're going to see what the refracted angle is, okay? And then you can use Snell's law in order to test your experiment to see how close it is with theory. Now, we're going to give you a bunch of different values for your incident angle. And let's say that I'm given an incident angle of 10 degrees, okay? That's my laser is going to come in at an angle of 10 degrees with respect to the normal. And I'm going to aim that laser toward the back center of my refraction cup, the point that's sitting right on the center of my protractor here. So my incident angle is right here at 10 degrees. You can kind of see that. And I'm going to look for my refracted angle up here. Okay, so I'm going to make an incident angle, and I'm going to take a pencil or a pen, and I'm going to mark as best you can that refracted angle. And remember, you're trying to hit the back center of your refraction cup. So let's maybe try it a couple of times, and you might want to get an average because your hands wiggle and wobble a little. Incident angle of 10 degrees right here was my refracted angle. Okay? Now I'm going to do an incident angle of 20 degrees from the normal. There's my refracted angle. I'm going to have an incident angle of 30 degrees. Here's my refracted angle. And then an incident angle of 40 degrees. There you can see my refracted angle. Barely. There it is. That's my refracted angle that I just marked up here. Oops, let's try that again. There, just barely coming through. Okay? So you see that actually there's two angles. You do get a reflection at this interface. You see my ray coming in is getting reflected over here, but it's also getting refracted on the backside. It's getting bent on the backside. And this is the angle we want to get this time, okay? So now that I've got those, I can remove my refraction cup. Oh, I should have, well, it doesn't matter. I'll flip this around. So I was at 90 degrees right here. This is my normal line at 90 degrees. And then I can use my protractor in order to get these angles. So maybe I'll start counting from here. I'm going to draw a straight edge just so I can get better estimation of these angles here. You're going to have to do a couple more angles than these 10, 20, 30, 40 ones that I did. I'm going to ask you to do some 5-degree increments down the middle. Okay, so this first one here was for my incident angle of 10 degrees. And I'm going to put my protractor right here, and I see that this one is at an angle of about, right here, 16 degrees from the vertical. So this one is labeled as 116 degrees, so 116 degrees minus 90, that gives me my refracted angle here. Incident angle of 10 degrees, my refracted angle was 16 degrees. You'll have to see what it is for your particular experiment. And then I do the same thing for my next angle. This one was an incident angle of 20 degrees, and then I'm going to have a refracted angle of greater than 20 degrees here in this case, and so on. Okay, so that's how you can do that experiment.